In Material Master, 7th view, MRP1. Under the MRP1 view, so the first field MRP group. So what is meant by MRP group? An MRP group is an object which you can use to assign common control parameters to a group of material for planning and organizational purposes. You can group materials using MRP groups. Each of the MRP group can have its own MRP parameter set. You can set the MRP group in the Material Master MRP1 view. MRP group can be maintained using transaction code /NOPPR. By assigning the MRP groups to a set of materials, allow planner to configure these materials to behave in a certain manner for planning purposes. All the materials in the group would then have unique planning method or unique planning features. Thus, the organizations can devise multiple MRP groups with their own planning features and characteristics rather than having one set of planning feature set to the plant level. So the next field in the MRP1 view, ABC indicator. Indicator that classifies a material as an A, B or C part according to its consumption value. This classification process is known as the ABC analysis. The three indicators have the following meanings. A means important part, high consumption value, which means we are going to use daily basics. Indicator B, less important part, medium consumption value, maybe we can use weekly once or 2 weeks once or few days in a month. Then the C, indicator C, relatively unimportant part, low consumption values. Maybe we can use monthly once or 3 months once, 6 months once. So you use this indicator to determine how the material is treated in the case of stratification for inventory sampling. So the next field, MRP type. This is the key which is used to regulate the material requirements planning. SAP MRP type also determines how and when the materials is to be planned or to be available for the requirement. There are several SAP MRP types that have been defined in the standard SAP systems. Please find the below the list of standard SAP MRP types. So let me go to SAP. I am going to show you the details. I am going to select one material. Under the Material Master MRP1 view, so these are all the MRP type, different type of MRP systems. So ND means no planning. So then PD, forecast consumption. R1, time based planning. VB, forecast based planning. VB, reorder point planning. So VM, automatic reorder point planning. So these are all the different type of MRP type. So based on the requirement, we can use in our Material Master. The next field in the MRP1 view, reorder point. In the reorder point planning procedure, the system compares available warehouse stock with the reorder level. If available stock falls below the reorder level, an order proposal is generated. The reorder level is made up of the sum of the safety stock plus the expected average material consumption within the replenishment lead time. So therefore, when determining the reorder level, you must take safety stock, previous consumption values or future requirements and the replenishment lead time into account. Safety stock must be set at the level which covers both excess material consumption within the replenishment time and the additional requirements which may occur during delivery delays. You must therefore take previous conception for or further requirements and the vendor's delivery timelines or that of production into account when determining the safety stock level. Types of reorder point planning. So we have two types. One is manual reorder point planning, another one is automatic reorder point planning. If you choose the manual reorder point planning procedure, you must specify both the reorder level and the safety stock level yourself and enter them in the appropriate material master record. If you choose the automatic reorder point planning procedure, then both the order level and the safety stock level are determined by the integrated forecasting program. The system determines the forecast values for future requirements by means of historical data. From these forecast values, the system then calculates the reorder level and the safety stock level for a particular material. So which is specified by the MRP controller and the materials replenishment lead time into account. So the next one, planning cycle. Key that determines the day on which the material is planned and ordered. The planning cycle is a planning calendar that is defined in customizing for MRP. In addition to the planning cycle, you can enter a delivery cycle which is defined in the planning calendar field. For example, it makes sense to enter a delivery cycle for the following situation. You carry out the planning run and place orders every Monday and Tuesday. The materials that are ordered on Monday are delivered on Wednesday, and the materials that are ordered on Tuesday are not delivered until Friday. So the system interrupts an additionally specified planned delivery time as the minimum delivery time, which means that at least this number of days pass between the planning run or the order and delivery. So the next one, planning time fence. The planning time fence specifies a period within which no automatic changes are to be made to the master plan. The planning time fence is maintained in work days. So the important note, it is only used for materials that are planned using an MRP type, which includes a firming type. The firming type determines how order proposals are to be created or scheduled within the planning time fence. So the next field, MRP controller. Material requirements planning controller is a mandatory field in material master. It represents the person or group that will be responsible of controlling the material workflow scheduling. The material requirements planning controller is the physical person that will be responsible for following the planning of the material requirements among its usage within the organizations. So the next one, lot sizing procedure within material planning. This is a setting by which we decide how the material will be produced or procured with a lot. Let's say Coke comes in a crate and one crate means 24 numbers. So if requirement is 70, by lot sizing procedure we can decide to have so 24 plus 24 plus 24 equal to 72 numbers. So my requirement is 70, but system will consider as a 72. Weekly and monthly lot size means this will propose entire requirement clubbing together in week or month. So this is the example. One crate means 24 number. Requirement is 70 number. So by lot sizing procedure, we can decide to have 24 plus 24 plus 24 equal to 72 numbers. My requirement is 70. Based on the lot size, I can get 72 numbers. So then minimum lot size. So what is the definition? Minimum procurement quantity of a receipt. This is my minimum lot size. So where we need to use this minimum lot size? If you define a minimum lot size, the system can only create receipts with a procurement quantity that does not fall short of the minimum lot size. To recover a requirement whose requirements quantity falls short of the minimum lot size, the system must create a receipt with the minimum lot size. You can use the minimum lot size for the following standard lot sizing procedure. The one is lot for lot order quantity, 2 period lot sizing procedure, 3 reorder point procedure. The minimum lot size is not relevant for manually creating a receipt. Here the system always creates a receipt with the required yield. Example, you have defined a minimum lot size of 100 pieces and the assembly scrap of 20% for a product produced in-house to cover an uncovered requirement of 40 pieces. 50 pieces must be produced altogether, taking the assembly scrap into account. Due to the minimum lot size of 100 pieces, however, the system creates a receipt with a procurement quantity of 100 pieces, so corresponding to the yield of 80 pieces. So, what is maximum lot size? Maximum procurement quantity of a receipt. So, where it is used? If you define a maximum lot size, the system can only create receipts with a procurement quantity that does not exceed the maximum lot size. To cover the requirement whose requirements quantity exceeds the maximum lot size, the system must create several receipts accordingly. You can use the maximum lot size for the following standard lot sizing procedure: lot for lot order quantity, period lot sizing procedure, and reorder point method. Example, you have defined a lot size of 100 pieces and an assembly scrap of 20% for a product produced in-house. To cover the uncovered requirement of 200 pieces, 250 pieces must be produced altogether, taking the assembly scrap into account. Due to the maximum lot size of 100 pieces, the system create two receipts with the procurement quantity of 100 pieces, each corresponding to yield of 80 pieces each, and a further receipt with a procurement quantity of 50 pieces corresponding to the yield of 40 pieces. So which means, so the maximum lot size 100 quantity, and we defined in the system assembly scrap is 20%. So to cover the uncovered requirement of 200 pieces, so 250 pieces must be produced altogether. So taking to the assembly scrap into the account, so due to the maximum lot size of 100 pieces, system will create three different receipt. First two receipt for 100 and 100 pieces, the last receipt for 50 pieces. So which means corresponding to the yield of 80%. So then the next field, fixed lot size. When planning used fixed lot size, the system will use the fixed order quantity recorded in the material master for the lot size calculation if a material shortage exists. If the fixed lot size is not sufficient to balance out the material shortage, the several lots are planned for the same date until material shortage is eliminated. So the next one, maximum stock level. You use the lot sizing procedure replenishment up to maximum stock level. If you want to fill the stock up to the highest possible level, or if you can only store a certain quantity of a material due to container size, this applies to a tank. For example, capacity of the tank determines the maximum stock level. So the next field, lot size independent cost. Costs that are incurred irrespective of a lot size for each purchase order or production order over the above the purchase order price or production cost. Use, where we need to use this independent cost. The ordering cost are used only for calculating the lot size in optimum lot sizing procedures. You must specify the ordering cost in currency of the company code belonging to the plant. So the next field, storage cost percentage code. So the key concept: storage cost indicator is a feature in SAP's material requirement planning component that allows user to calculate the cost of storing materials. It takes into account factors such as the cost of the material itself, the cost of the storage space, and the cost of labor associated with the storing and retrieving the materials. This indicator helps user make informed decisions about their inventory management and storage strategies. How to use it? To use the storage cost indicator, users must first enter the relevant data into SAP MRP system. This includes information about the material being stored, such as its cost, size, and weight. Users must also enter data about the storage space, such as its size and cost. Finally, users must enter the data about labor cost associated with the storing and retrieving materials. Once all this data is entered, the storage cost indicator will calculate the total cost of storing the material. So the next field in the MRP1 view, assembly scrap in percent. Percentage scrap that occurs during production of the material if the material is an assembly. Use. The assembly scrap is used in material planning to calculate the lot size of the assembly. The system increases the quantity to be produced by the scrap quantity calculated. So, if the material is an assembly, specify the percentage scrap as required. For example, if the quantity to be produced is 200 pieces and you specify an assembly scrap of 10%, which means you have to produce 220 pieces, then only you can get the output of 200 pieces. So the next field in the MRP1 view, talk time. Talk time is a tool for setting the pace and rhythm of your manufacturing process and aligning it with customer demand. As a metric, talk time is the amount of time to manufacture each part, such as producing one part every 22 seconds. As a tool, it helps you to establish flow and eliminate waste in your process. So, what is the talk time formula? Talk time is traditionally calculated from available production time and customer demand. In other words, take the amount of production time you have available for running your process, which by convention include budgeted downtime and exclude changeover and breaks, and divided that time by the number of pieces you need to manufacture to meet customer demand in order to determine how much time you have to manufacture each pieces. So talk time equal to available production time divided by customer demand. This is the formula to calculate talk time each and every product. So in MRP one view, the next field, rounding value. You use a rounding profile if you want to round the procurement quantity up to quantities which can be delivered or transported. Rounding value for purchase order quantity. So value to a multiple of which the system rounds up the procurement quantity. The rounding value is used in the planning run if no rounding profile has been specified in the material master record. As your rounding value is 15, system will create demand in multiple of 15. If your rounding value is suppose 40, in MD61 having the requirement of 110, then the demand created by system will be 120. Example, your raw material requirement quantity is 110, rounding value is 40, system will do like this. So 1 is to 40 does not meet the requirement. So 2 rounding value equal to 80 does not meet the requirement. 3 rounding value equal to 120 meets the requirement. So it will create a procurement proposal for 120. It may be a planned order or purchase requisition. So this is how system will taking the rounding values. So the next one, rounding profile. A material's base unit of measure is 1 piece. The material is to be transported in layers. One layer corresponds of 5 pieces, or in pallets, one pallet corresponds of 8 layers, which corresponds of 40 pieces. You have defined the following rounding profile in customizing. So from a requirement of 3 pieces, the system round up to 5 pieces. From a requirement of 33 pieces, it rounds up to 40 pieces. The system then calculate the procurement quantities as follows. For a requirement of 8 pieces, the system checks how many times 5 fits into 8. The results in a procurement quantity of 5 pieces, 1 into 5 equal to 5. The system rounds up the remaining 3 pieces to 5 pieces. Thus, for a requirement of 8 pieces, one procurement proposal is created for 10 pieces. So, for a requirement of 33 pieces, the system checks how many times 40 fits into 33. The result is procurement quantity of 40 pieces, 1 equal to 40. The system rounds up the remaining 33 pieces into 40 pieces. Thus, for a procurement of 33 pieces, a procurement proposal is created for 40 pieces. For example, this is my requirement quantity and this is my procurement quantity. Based on the pallet or the container size, system will determine the procurement quantity against the requirement quantity by using the rounding profile.